This will be the 5 steps. So again, we're gonna need to state the hypothesis and identify the claim. We're gonna have to find the critical values, compute the test statistic using the formula. We make the decision to reject or not reject the null hypothesis, and then we summarize the results. So let's see an example about hospital infections. A medical investigation claims that the average number of infections per week at a hospital is 16.3. A random sample of 10 weeks had a mean number of 17.7 infections. The sample standard deviation is 1.8. Is there enough evidence to reject the investigator's claim at alpha equals 0.05? Assume the population is normally distributed and use the critical value method. So we need to have this sentence here that the population is normally distributed. We need this assumption because the sample size is just 10. It's not greater than 30. It's less than 30. If the sample size is greater than 30, we don't need this assumption. Now, let's see what would be the claim in symbolic form. The medical investigation claims that the average, so this is what is telling us that this is a problem about a mean, because the claim is that the average number of infections per week at a hospital is 16.3. So this would be what? The mean is how? Equal, not equal, less than, greater than. It would be equal. So the claim is that the mean number of infections per week is 16.3. So if that's the claim, where do we write it? In the null hypothesis or in the alternative? In the null hypothesis, because we have the equal sign. Mu equals 16.3. So what will be the alternative? Not equal. When the claim is that the mean is equal to a number, then the alternative is that the mean is not equal to that number. So what type of test is this? Left tail, right tail, or two-tail? It's a two-tail test. So we're gonna need to find two critical values, one negative and one positive. And we're gonna have two rejection regions, one to the left of the negative critical value and one to the right of the positive critical value. So we're gonna use alpha 0.05, and we need also df, the degrees of freedom. So what's the sample size? How many weeks were considered? 10. So n is 10. So df is n minus 1. So 10 minus 1, 9. So using table F, we're gonna find the critical values. It's 0.05, right? Yes, 0.05, and df is 9. And the test is two-tailed, so we need to find alpha where it says two tails alpha. 0.05 is here, and df equals 9 here. So in the body of the table, we obtain the number 2.262. So what will be the two critical values? 2.262 and negative 2.262. Very good. So here we're going to have negative 2.262 and here 2.262. So now we need to find the test value. So when you're testing a claim about a mean, the test value is t equals the sample mean minus the value of the mean in the null hypothesis divided by the sample standard deviation over the square root of the sample size. So what's the sample mean in this example? Now we use the information from the sample. The sample mean is 17.7. So that's the number that we're going to plug it in. Minus, what's the value of the mean in the null hypothesis? 16.3, yes. Over, what's the standard deviation of the sample? 1.8. So over 1.8 divided by the square root of 10, because n is 10. Now, to evaluate this formula, you need to put a parenthesis here in the denominator. And you can put the parenthesis also in the numerator unless you do this difference first. So I usually do the difference first. I say 17.7 minus 16.3 and I press equal. So now I can press the division, open parenthesis, 1.8 divided by the square root of 10. So what do you obtain if you round to 2 decimals? What's this value when you use your calculator? .46. So this is the test value. So now we can make the decision. If the test value falls in the rejection region, in one of the rejection regions, then we reject the null hypothesis. And if it's outside or in the non-rejection region, we fail to reject. So in this case, 2.46 is in the rejection region because it's greater than 2.262. So the decision will be reject the null hypothesis. So if we reject the null hypothesis, what will be the answer to this question? Is there enough evidence to reject the claim? Do we have evidence to reject the claim? In this case, yes, because the claim is the null hypothesis. And we are rejecting the claim. We are rejecting the null hypothesis. So the conclusion will be there is enough evidence to reject the claim. So we can reject the claim of the medical investigation. The sample is telling us to reject this claim. The mean number of infections is not 16.3. Could be less or more, but not equal to 16.3. So this is how we solve a two-tailed test for testing a claim about a mean using the critical value method. So we have the solution with the test value, the critical values, one positive and one negative. The test value 2.46 falls in the rejection region, so we reject the null hypothesis. And the conclusion is that there is enough evidence to reject the claim that the average number of infections is 16.3.